Hi guys, you're welcome to Halogenious Ideas. In this tutorial, I'll show you how to find the distance in miles and kilometers between two locations. You will have to supply the address of the first and the second location, and with Python, you'll be able to find the distance between both locations. So we are going to be using this Python package, GeoPy, and we are going to be using this geocoder called Nominatim. Okay, Nominatim is what we are going to be using. If you check their documentation over here, we have so many functions available: the search, the reverse, the lookup, the status, and you can see what they do. So basically we will have to geocode, convert the address to the longitude and the latitude. We're trying to find it, then we are going to be using that data to calculate the distance between both addresses. So let's just go straight into VS Code. We start by installing GeoPy. Pip install geopy. If you don't have that installed, you can just do that quickly. Then you import Nominatim from geopy.geocoders. Import Nominatim. Then no, this should be capital M. Then you create a geolocator, but before that you also have to import distance. So from geopy import distance. Okay, then you create a geolocator, which is a nominatim object. So geolocator equal to nominatim. You pass in a user agent, so you can just pass in the name of your application over here. So HID training. Then the next thing you want to do is to bring in both addresses. So let this be address 1, then this other one will be address 2. So you have to pass in the full address of the two locations over here. So let me come here and find University of Manchester, England, full address. So let me use this full address. Okay, so let me just copy this. So this will be my address 1. So I want to find the distance between University of Manchester and University of London. So come back here, University of London. So okay, so this is the address for University of London. Copy, then I'll bring it here. So I want to find the distance between these two addresses. So the first thing I will have to do is to get the geo coordinates, the longitude and the latitude of both. So how can I do that? I can just say location 1 equal to geolocator dot geocode, then address 1. Let me just copy this, then I'll bring it to the next line, but this is going to be okay. So the location 2 is going to be geolocator.geocode address 2. So let me print the two of them, so when we are debugging we know exactly what each output is giving us. So print location 1, then also print location 2. Okay, now that I've printed the two of them, basically these are going to be giving us the actual address, the full address of these two locations as registered on openstreetmap.org. Then after doing that, the next thing we want to do is to structure the coordinates into something we can pass into the distance, which is basically a tuple of two elements. The first element is going to be the latitude, the second element is going to be the longitude. Okay, so coord 1, which is going to be the geo coordinate for the address 1, which is the address of the University of Manchester. So I'll bring in a tuple, then I can do location 1 dot latitude, then The second element will be the location 1 dot longitude. Okay, location 1 dot latitude, then the second one will be location 1 dot longitude. So the second one will be the coord 2. So for the coord 2, I'll just change all the ones to 2. So basically location 2 dot latitude, location 2 dot longitude. Okay, so coord 1 and coord 2. Now to find the distance, we have different two different calculations we can have. If you come here under geopy, then you come under calculating, under installation, you will see something around here, calculating distance. So calculating distance, exactly. So under calculating distance, if you come here, you will see the geodesic distance, which is the default for geopy.distance, is the shortest distance on the surface of an ellipsoidal model of the earth. Okay, we also have the great circle distance. The great circle distance uses a spherical model of the earth. Okay, so using the mean earth radius as defined by the International Union of Geodesy and Geophysics and all that. So we are going to be using both of them. So you see the results both of them will be given. So moving on, we are going to start by calculating the geodesic distance. So geodesic distance. So for the geodesic distance, since it's the default, you can just say d default. So this is going to be, don't forget we imported distance over here. So I'll just say distance dot distance. Okay, don't forget geodesic is the default, so I can just pass coord 1 comma coord 2, and basically for me to get the distance in miles as calculated by the geodesic distance function, I can just print, so d underscore default dot km. So this will give me the result in kilometers, then this other one will give me the result in miles, so I just have to say miles. Okay, but if I want to use the great circle calculation, so great circle distance, so I'll just say dgc. Let me just use this so I won't have to type a lot. So I will just say distance dot great circle dot great circle, then passing coord 1 comma coord 2. And after doing that, basically the same thing I did here is what I'll be doing. So let me just copy it, then come here and paste it, but I'll be using this. Okay, and I think that is all that we have to do. We started by importing all the required classes. We brought in the geolocator, then we have our two addresses. You can see we geocoded the two addresses. Now we have the full address as registered on OpenStreetMap. Then we extracted the longitude and the latitude and made tuples out of it. Then we calculated our distance. We displayed both in kilometers and in miles. So let me print distance in using geodesic calculation. Okay, while this other one will be distance using great circle calculation. Great circle. Okay, great circle calculation. So save this, and now we run our code. Now we run our code. Okay, so So you can see for this first one, you can see Oxford Road, Manchester M13. You can see Oxford Road, Great Manchester M13. Then for the second one, Senate House, Mallet ST. Okay, Mallet Street. Okay, WCIE 7. You can see exactly. I think this one is more detailed. What we have in OpenStreetMap is more detailed than even what we got on Google. So after geocoding and we got everything that we need to get, according to the geodesic calculation, you can see the distance. The distance is slightly different, okay, slightly different, but if you do a trade-off, you'll be able to calculate which one works for you. Okay, you'll be able to get which one works for you. So, and that is it for this tutorial. You can see the default, which is in kilometers. Then you can see the one in miles. For the grid circle calculation, you can see the calculation in kilometers, and you can also see it in miles. So basically, that is all for you calculating the distance between two locations, provided you supply the address of the first one and the second one to this Python script over here. So I believe you can easily plug this into your Python code. So thank you very much for staying till the end. Don't forget to like the video and subscribe to the channel. I'll see you in the next tutorial. Bye for now.